Welcome back everyone to West Explains Best. Today we're going to be discussing section 8.1, which is completing the square, and also the square root property. So let's go ahead and get started. For any Algebra 2 student, you've probably already seen this before. For those that have taken a freshman college course or senior level math course, algebra course, this is mostly going to be a review, but I'll try to explain it so even if you haven't seen this before, it will make sense. So a quadratic equation is in the form where you have an x squared. So here we have the x squared, but there could be a coefficient a, and then the x term could have a coefficient. We'll call that b. And then there could be a constant added or subtracted on there when we call that c. So ax squared plus bx plus c is the generally agreed upon form for a quadratic equation. That's an ugly line. There we go, that's better. Okay, one of the conditions is a cannot be equal to 0. And the reason why is because then it would just be a linear equation. It wouldn't be a quadratic anymore. So the x squared is essentially essential to have. You can take or leave these two guys, but it cannot. The coefficient of a cannot be equal to 0. Now, when we're talking standard form, we're talking about decreased order. So the x squared needs to be first, the x needs to be second, and then the number, whatever it is, we'll just put number here for a second just so you understand what I'm talking about. It needs to be third, and it needs to be equal to 0. This is an important part. You want it equal to 0 because this will help you do some factoring, and then you can find some values for x. So setting it equal to 0 is really important. That's really what we're considering standard form. That's why it's written here too. It has to be set equal to 0. Okay, so let's talk about the zero factor property. So if we have two variables, a times b equal to 0, then either a or b could equal 0. Let me give you like an example. So if a equals 3 and then b equals 0, we could have 3 times 0. What does that equal? That gives us 0. Now let's say we had a equals 0, but then b equals, I don't know, 2,000. Well, same case, same truth still holds. 0 times 2,000 still equals 0. So if a equals 0 or b equals 0, then that will make a true statement. This is very useful for when we have parentheses. It says solve for x here. Well, using the same principle we just learned, if this parenthesis equals 0 or this parenthesis equals 0, then these will make a true statement because it's equal to 0 on the other side of the equal sign. All we have to do from here then is set x minus 5 equal to 0, and then 3x minus 8 equal to 0. And then we solve for x, and we can figure out what values of x make each parenthesis go to 0 so that it makes a true statement. The left side's a little bit easier. We just need to add 5 to both sides, and we get x equals 5. And that makes sense because if we have 5 minus 5 times 3 times 5, that's 15 minus 8, that is equal to 0 times 7, which equals 0. We don't even really care what this other parenthesis is because we already know that this one's going to equal 0, and if that's equal to 0, then anything multiplied by 0 will give you 0. So I just wanted to show you guys why it's important that you set each both to 0 and the power it gives in finding our solutions. Now we need to add 8 to both sides here. So we have 3x minus or equals positive 8, and we divide by 3. And we get x equals 8 over 3. And that's our other answer. So both of these answers satisfy this equation. One of the most surprising answers I get is, oh, my answer has to be wrong because I have a fraction. No, it's okay. Just because you have a fraction doesn't mean you did something wrong. Actually, in life, in the real world, when you have fractions, that's going to be probably most of the time you're going to have fractions and decimals and something that's not exact. Okay, so we're going to move on to the next example. So we have 3x squared minus 5x minus 28. All right, now this is already in standard form. It's in decreasing exponent order, and it's equal to 0, so we're ready to rock and roll. I hope you guys remember that we can make 2 parentheses here, and then we can factor it into these 2 parentheses. What I like to do is, I think this helps with awareness in terms of number sense, is I don't like the AC whatever method of finding the factors, whatever. I just like to put 3x and x, and then I play around with different numbers of 28 that go here, in here, that will, once I FOIL it out, it will equal the trinomial above. Okay, and I'll show you what I mean by that. This is review. If you want to see more in depth, that's a different video. But I just wanted to give a quick sum up of how I approach it because I know some teachers are different. Okay, so then I have negative 28, and I know some factors are negative 7 and 4. If I put a negative 7 here, I know I'm going to get too big of an answer, and one has to be negative and one has to be positive because this term is negative. I know I'm going to get too big. I'm going to get 4x there, and this is going to be negative 21. So that's too big. I can't do that. But if I switch the 4 and the 7, I think we're good. So I'm going to switch the 7 and the 4. So 7 I'm going to put here, the 4 I'm going to put there. But I'm going to make the 4, oh, the 4 is negative. We're good to go because I know the negative needs to win because the middle term is negative. So I factor this correctly. I can double check that because that's 7x. This is negative 12x, and then those combine to give us 5x. We're good to go. Okay. That besides the point, we set 3x plus 7 equal to 0. We set x minus 4 equal to 0, and we solve these two separate problems. We should get x equals 4 after we add 4 to both sides. We should get 3x equals negative 7. Divide by 3. That's a 3. Believe me. Negative 7 over 3. So we have two answers, and there they are. And that is the basis of the zero factor property. The square root property. If x squared equals k, then x equals two things. So we have two blanks here that we need to fill in. One thing is, of course, the square root of k. Why wouldn't it equal that? But we also know that it could equal the negative square root of k. Most of the time when we're talking about square roots, we're talking about the principal square root. This is the principal square root right here. That means only the positive square root. The negative square root doesn't often get love in math, but technically the square root property, we should include both positive and negatives. They are both valid answers. Why is that? Well, if we take the square root of 9, we know that, I'm going to keep using this green, that square root of 9 is 3, or it's negative 3. Why is that? Well, positive 3 times positive 3, of course, is 9. That's why our square root is 3. But a negative 3 times a negative 3 is also 9. So a negative 3 is also our square root. Now how do we apply this? Well, what we're going to do is we are going to square root both sides of these equations. So we're going to square root this side and we're going to square root the right side. So we get x equals, now there's two possibilities. We can have plus or minus the square root of 5. We have two answers there. Keep that in mind. Now the key is here, look, we have 4x squared minus 48. Looks a little difficult, but what we should do is it's essentially inverse operations. We need to move everything over to the other side. So we have 4x squared equals 48. We divide by 4. Divide by 4. We get x squared equals 12. And then we take the square root of that. This gives us x equals plus or minus. There's a positive version and a negative version. And then we have square root of 12. We can simplify the square root of 12. This is another video, of course. But just a quick sum up. I like using the factor tree. Factor tree gives us 2, 6, 2, 3. We have a pair of 2's. One's going to leave the house. 3 stays home. So this becomes plus or minus 2 radical 3. And there's my answer. Moving on to the third example. Again, we need to get the x by itself. I subtract 5 on both sides. I get 3x squared equals 6. I need to divide both sides by 3. I get x squared equals 2. I need to take the square root of that. And I get x equals plus or minus the square root of 2. Lastly, we have a binomial, and that's squared, and that equals 36. This is actually not as bad as it sounds. We take the square root first, because we're going to do inverse order of operations. We're going to start with exponents after we move other stuff to the side. Of course, we didn't start with exponents in this one. We want to move stuff to the other side first. But since this parentheses is kind of by itself, we want to get inside the parentheses, so we take the square root first. So we get x minus 5. We can take out the parentheses because there's nothing else affecting it, equals. All right, so now we have two things. One is x minus 5 equals 6. And then we have x minus 5 equals negative 6. So we're going to have two answers again. We're going to add 5 here, add 5 here. We get x equals 11, or add 5 here, add 5 here, x equals -1. We have two answers, just like we did with all the other ones, and we can verify this. So if we have -1 minus 5, and we square that, well, -1 minus 5 is -6. We square that, we get 36. If we have 11 minus 5, that gives us 6. We square that, we get 36. So both of these are the correct answer. Make sure you account for that by splitting it up into a +6. Well, let me hold it right here. +6 and a -6. Okay, that's the end of this video. In the next video, we're going to talk about completing the square. It's a really useful topic, and I'm definitely positive that you're going to need to know this for pre-calc, for Algebra 2, and maybe even algebra. So see you soon.